All right. Hello, everyone. Thank you very much for joining us in this session. My name is Nima Kaviani, and I'm a Principal Solutions Architect with AWS. I'm here with my good friend, Brandon Leach, who's a software architect with Autodesk. And we are going to talk to you about the engagement that we've had in order to build a deployment tool that allows you to have your software system deployed across multiple regions in a matter of minutes. For the agenda, we're going to talk about what multi-region is and why you care about multi-region or need to care about multi-region. Then we're talking about AWS and the different service supports that we have for multi-region. Then we're going to talk about who is using multi-region. Then I'm going to hand it over to Brandon, who's going to talk about our Autodesk engagement to enable a multi-region for Autodesk and show a demo. Okay, so why would you do multi-region? It's mostly about business continuity. The idea is that you want to have your services up and running for your customers all over the world without having them to face interruptions, right? So what you do is that you end up taking your software stack and distributing it across multiple regions in the world. So in case, disaster hits, you can actually redirect traffic from one region to another. Now, there are different strategies that people actually enable multi-region. One of the primary ones is something that's called backup and restore. So essentially, you take the data tier for your software stack and you distribute it across multiple regions in the world. Now, in case of disaster, if you need to recover from it, you bring the data that you've backed up, you restore it, and then you bring up the rest of your software stack in order to make the software available to your users again. So obviously, the problem with this is that because you need to still build a bunch of services for your software stack for it to be operational, there's going to be some amount of time before your software is up and ready. Also, depending on how frequently you've been backing up your data, there's going to be some data loss that may incur as a result of the time between when the disaster happened and when the last time you actually backed up your data. A second strategy is what's called a pilot strategy. In this strategy, on top of backing up your data across multiple regions, you actually take a piece of your software stack, which is core to your software, and replicate it across multiple regions, right? So when disaster hits, then similar to the previous strategy, you still need to restore your data, and also you need to bring up the rest of the services for your software. But because you already have the core piece of your technology up and running in multiple regions, there is going to be a quicker time to recovery in terms of bringing up the rest of your software stack. In terms of data loss, you're going to be in the same boat as the previous strategy, depending on how frequently you've been backing up your data. The third strategy is something that's called warm standup. With warm standup, what you do is that you actually keep a full replica of your software stack in a different region or in multiple regions, but in a scaled down version. And you do not redirect traffic to this basically copy of your software system. It's just like there for when it's needed. So when disaster hits, then you quickly scale up your warm standby to a scale that is capable of taking your production load, and then you redirect traffic. And obviously, because you've been constantly backing up your data, and because you've been able to, very quickly scale up, hopefully, then the recovery time is a lot faster, and you're not going to be dealing with a lot of data loss. Finally, the last strategy is something that's called active-active. And in the active-active model, you actually keep a full replica of your software across multiple regions. So when disaster happens, all you need to do is to just redirect traffic from one region, the one that's faced disaster, to another one. And because you've already been taking care of replicating data and your software stack in the other region is production ready, you can very quickly come back to operation and respond to failures. So in terms of how quickly you are actually able to recover, this is the most efficient one. One thing to note, though, is that as you actually go from the bottom to the top in the options or the strategies that you can have, you're going to end up spending more money because you're going to utilize more resources. So that's something to be aware of. Now, you may ask at this point, okay, why do I need to care about multi-region? So the primary one, obviously, as I've been discussing so far, is disaster recovery, right? If your software goes down in one region, you do not want to leave your users out of service, right? So, for example, if you have users in the US using your services in US, and you have users in Australia using your services in Australia, and for whatever reason your data or your application services go down in the US, you want to be able to redirect users to the deployment you have in Australia and have them use your service or continue with their using of your service. The other reason is to improve latency and performance of your software system, right? Geo-proximity is an important concept when it comes to multi-region. And if you have your software stack closer to your users, they're going to have a better experience using your software. So, for example, if you have users in Europe, it's going to take them 140 milliseconds to access your services in the US, but 300 milliseconds if they want to access your services in Australia. Obviously, if you deploy your services in Europe, then they're going to take less than 10 milliseconds to access your resources. So the user experience is a whole lot different. Lastly, there might be some business and compliance requirements that your business needs to deal with. For example, if you're dealing with personal information for your users in Canada, based on the laws of the government of Canada, those information are required to stay in Canada. As a result, you may end up deploying your software in Canada in order to ensure that your data stays in Canada for your users. So now that you hopefully have seen enough reasons for why you want to do multi-region deployments, let's look at some of the challenges with having multi-region deployments. One of the challenges is network challenges, right? Throughout this conversation, I've actually talked about how you take one piece of your software and put it in one region and take another piece of your software and put it in a different region. The question is, how are you going to get the pieces of your software to actually communicate with one another? One easy way is to actually have internet gateways for your VPC setup in your AWS deployments, and then connect those internet gateways to one another and have your software from one region access resources or services for software in another region. Well, obviously, you don't want your data to go over the internet unencrypted, so you probably will end up adding some VPN software to your VPC that encrypts your data before it leaves your VPC. So there's still a problem though, because your data goes over the internet. And internet is a jittery, busy place, and you're going to have some interruptions that you may have to deal with. So the better strategy in order to improve the performance of your system and the stability of your system is to use VPC peering. And the idea is that for the different VPCs that you have in your setup across regions, you actually peer them with one another, and then the data uses the Amazon infrastructure and the Amazon networking in order to go from one region to another. So there's going to be a lot less interruption in the data transfer. Also, the moment your data leaves your VPC in one region, it gets encrypted before it makes it to the VPC in the other region. And the downside of this design is that you have to do VPC peering for each pair of your VPC instances. So the network setup can get out of hand very quickly. So a better idea that we've been recently promoting has been to use transit gateways. And with transit gateways, you can actually set up a transit gateway in each single region, and you can connect all the VPCs in one region to that transit gateway, and then only connect transit gateway in one region to the transit gateway in another region. And as a result, the complexity that you're going to have to deal with for your network is going to be reduced significantly. So that's the recommended way for the network setup. The other challenge that you have to deal with is with regards to persistence of your data. If you noticed when I was talking about the different strategies of enabling multi-region, one of the primary aspects was to be able to replicate your data from one region to another. Now, there are a bunch of AWS services, a number of AWS services that allow enablement of inter-region persistence of data across multiple availability zones readily and out of box. So you see in this slide I talked about multi-AZ, but it's important to note that every region, every AWS region has multiple availability zones, and you can make it so that your availability zones are configured across different regions. So with the services on the left here, for example, Amazon S3 or EFS or DynamoDB or QLDB, you get a multi-region support out of the box. With few clicks and configurations, you can make it so that once you upload the data to, for example, an S3 bucket in one region, it gets replicated in a different region And so you have that consistency across your different instances of S3 buckets without doing anything, right? It is readily available to you. With the services on the right, there is possibility for configuring multi-AZ and multi-region support. It's a little bit more challenging, but it's certainly still doable. And so, for example, if you have Elasticsearch or RDS or Aurora or other type of services, you can configure them so that they actually replicate your data from one region to another, so you can have that eventual consistency across regions. And as a result, if you happen to want to shift your load from one region to another, the data is there in the new region for you. Out of all these ones, and there are three services, Amazon Aurora, DocumentDB, and Neptune, that actually have support for multi-AZ out of the box to a good extent. They already replicate your data across 6 different AZs in some cases. And as a result, you get a lot more flexibility in terms of using Neptune or Aurora when it comes to using them as the persistence data store. So the point here is that AWS services actually come a long way in enabling you to be able to have multi-region strategies in your software deployment. Finally, the last challenge that you'll have to deal with is the deployment strategy that you use and how you're going to actually make sure that you get your software deployed across multiple regions. Now, if you use services like CloudFormation or Amazon CDK, there are some features, functionalities, and library in there that allow you to do multi-region deployments. But if you want to use third-party CI/CD applications, for example, Argo CD or a Spinnaker or Terraform or Pulumi, there's going to be a little bit more configuration that you have to deal with in order to ensure that you can actually achieve multi-region deployment. For example, in this particular talk, we're going to focus on a Spinnaker and how in the collaboration that we've had with Autodesk, we've enabled Spinnaker to more easily support multi-region deployment of applications. So who is doing multi-region? Among AWS customers, I can name 3 that have been quite vocal about their multi-region strategy: Netflix, Autodesk, and Capital One. So with Netflix, they released a technology called Nimble in 2018, where they talk about their multi-region support and how they actually enable the failing fast strategy for their deployments, and in such a way that, for example, if the one region goes down, they can very quickly recover and you very quickly have the software systems or services that they require up and running in another region. And they talk about how they actually use dark capacity and create extra capacity so that they can switch when they need to. Very interesting blog post. If you're interested, I highly recommend that you go and have a look at the reference linked in this slide. Capital One also, they have a blog post talking about their Terraform strategy, their configuration approach to enabling multi-region, and how by configuring their Terraform templates, they can, by tweaking some knobs in their deployment strategy, very easily go from having their software deployed in one region to having it deployed in another region. So there's definitely a lot you can do with multi-region, but you notice that I deliberately put Autodesk out of the examples that I mentioned, and that's because at this point I'm going to hand it over to my good friend Brandon, who's going to talk about Autodesk approach to multi-region. Over to you, Brandon.
Thanks, Nima. My name is Brandon Leach, and I'm a software architect at Autodesk. Today I'm going to talk about Autodesk's approach to multi-region service deployments. But first, a little bit about Autodesk. We make software for people who make things. We're a global leader in design and make software for the architecture, engineering, construction, entertainment, and manufacturing industries. If you've ever driven a high-performance car, admired a skyscraper, used a smartphone, or watched a great film, chances are you've experienced what millions of Autodesk customers have built with our software. To enable the complex workflows that allow cross-functional distributed teams to collaborate on taking manufacturing, construction, movie and game designs into reality, Autodesk has built hundreds of cloud services that run in AWS. AWS provides us tons of excellent services to build upon, but we ran into many problems when it comes to expanding to new regions. Here's a quote from Ben Cochran, who manages the org that's working on this effort. Making our products and services available in new regions takes months. It needs to take minutes. There are simply too many manual steps and decisions that needed to happen to launch a service into a new region. To close this gap, we kicked off an effort to rebuild much of our service delivery and cloud infrastructure automation. We asked ourselves if expanding a service to a new region could be as simple as making a pull request. That's the journey I'm going to talk about today. First, I'm going to talk about some of the architectural and technology choices we have to make. And then I'm going to go a little deeper into the implementation of our automation, followed by an end-to-end demo of our new multi-region deployment workflow. One of the first areas we had to examine was the mapping of AWS accounts to services, regions, and environments. There are many considerations we had to take into account when refining this strategy. There were security concerns. We needed to ensure that the segmentation we were providing would support our IAM authorization strategy. Scalability. We had experienced many problems in the past with large multi-tenant accounts hitting AWS API rate limits that cause system instability. And ease of automation. We aim to remove any ambiguity about what account a service should be placed based on its region and environment coordinates. And finally, billing and tax regimes. There were many billing and finance requirements related to rolling up costs and geographic regions to specific AWS account pairs. So in the end, we settled on a more segmented account strategy, where there's an AWS account per service, per region, per environment. This provides us the increased service and resource isolation we were looking for. And it's also easier to automate because the relationship between a service, region, and environment is granular and predictable. There's also the added benefit of simplifying the management of AWS API rate limits and billing. But the challenge with this increased segmentation is that it increases the setup overhead for a service, for creating a new service and adding a new region to a service. We now have to create accounts and associated networking. We built a service registry and account networking provisioning service to address these challenges that we'll look at in a little bit more detail later. Another decision we made was to replace a set of in-house built software with an open source continuous delivery platform called Spinnaker. Spinnaker came out of Netflix and has quickly become industry standard continuous delivery platform. Spinnaker allows you to build pipelines to orchestrate deployment workflows using immutable infrastructure and provides an elegant abstraction between your deployment logic and the underlying reference runtime. We use Spinnaker to deploy EC2 for VMs, ECS for containers, and Lambda for serverless. Another strength of Spinnaker is the size of the Spinnaker community itself. Many of the major cloud providers are contributing to Spinnaker, and as we'll see later, the ability to work with AWS and the open source community to add new functionality to Spinnaker has been a big win for us. For infrastructure that's not directly managed by Spinnaker, we use Terraform. Terraform allows us to manage things like load balancers, data stores, S3 buckets, all associated infrastructure for a service. But actually, Spinnaker and Terraform are very complementary. We utilize Spinnaker's ability to run Terraform in the context of a deployment pipeline to allow for the management of all service components. This capability allows us to manage all infrastructure related to a service using Spinnaker pipelines. Another step we took was to abstract away the complexity of Spinnaker pipelines, Terraform, accounts, and networking by implementing a declarative interface called an application definition file, or ADF for short. The goal of the ADF is to provide a declarative interface with a GitOps workflow that eliminates the boilerplate configuration needed to create and manage a service. Engineers can simply outline the infrastructure and service deployment requirements for their service and not have to worry about the complexities of building Spinnaker pipelines or Terraform. In order to enable this pattern, we built a tool called Skipper, which consumes the ADF and renders the needed Terraform and Spinnaker pipelines needed to deploy a service. Skipper also integrates with our service registry and account and networking provisioning automation, which we'll get into a little bit more later. So let's look at an example of the pipeline configuration section of an ADF. This section contains the deployment process requirements for a service. Here you can configure things like CI triggers, where notifications are sent for this service, what kind of resources being deployed, for example, EC2, containers, or Lambda. And most relevant to our discussion today, in the deployment section, you can specify the environments and regions required for your service, along with whether or not manual approvals are required for promotion between environments, and the type of multi-region strategy to utilize. Right now, we support the option of deploying regions either in parallel or serially. So let's take a step back and look at how this works end to end. So step one, the user adds the new requirements to the ADF. In this example, a new region for an environment. Then in step two, these changes are pushed to GitHub, then Jenkins, where all CI tasks are ran and the ADF artifacts are packaged. In step three, the preliminary Spinnaker pipeline is triggered, which consumes the ADF. In step four, the environment and region requirements are retrieved from the ADF, and a request is made to our service registry for the required account coordinates. If the ADF contains new region requirements, and in this example it does, in step 5, a call is made to our account and networking provisioning system to create the needed accounts and set up networking. And once complete, the new coordinates are stored into the service registry and passed back to Spinnaker in step 6. Then Skipper is called to render the service deployment pipeline in step 7. There's a problem here though. The problem is that in order to load new accounts into Spinnaker, you need to edit a static configuration file and restart a Spinnaker service called Cloud Driver, which is responsible for executing all read-write operations in Spinnaker. So we could automate this flow from ADF, change to the ADF to rendering the needed Terraform and Spinnaker pipelines, creating the accounts and networking, but we still had a manual step. This problem was compounded by the fact that restarting Cloud Driver is a pretty heavy operation that could impact the execution of current deployments running in Spinnaker. In order to solve this, we engaged our friends at AWS and Armory with the proposal of collaborating on adding dynamic account registration to Spinnaker. We wanted to make sure that the solution we were building was not specific to Autodesk, but something that could benefit the larger Spinnaker community. This project is now just wrapping up, and the code has been merged into open source Spinnaker. So looking back at the end-to-end flow, Spinnaker now has another path for loading account configuration. With our new plugin, when Cloud Driver comes across a new account, it calls out to our service registry in real time to retrieve the needed configuration. This lazy loading of account configuration enables us to automate the deployment of services to new regions with our segmented account strategy. Now I'm going to hand off to Cole and Gaurav to demo this workflow end to end.
Thank you, Brandon. Good morning, good evening, and good afternoon. My name is Cole Duclos, and I'm a Senior Principal Engineer for the Cloud Platform team at Autodesk. Today I'm going to demonstrate end-to-end how Autodesk deploys services into new regions with Spinnaker. Here we can see an application definition file, or ADF, for the Acme service. As shown, this service is deployed into US West 2 of our development environment and US East 1 of our staging and production environments. This ADF translates to a full deployment pipeline in Spinnaker. Here is an example of a successful deployment in the environments and regions specified. At the moment, we have 3 AWS accounts listed: Acme C UW2, the development stack in US West 2, Acme S UE1, and Acme P UE1, the staging stack and production stack in US East 1. Looking at the stages in the pipeline, we can see for each environment and their respective regions, steps for onboarding the account, deploying some tests, and deploying the application itself. To quickly verify the application is deployed in US East 1 of our production environment, we can find its load balancer under the Infrastructure tab. Here you can see the domain name of the load balancer deployed in US East 1. If we click on the link, we can see our Acme Fox application healthy and running as expected. Now, to deploy the service to a new region, it's as simple as making a quick addition to the ADF. Let's say we want to deploy Acme into the EU West 1 region of Europe for a production environment. I can add EU West 1 to the ADF and save the change. Once I push those changes to GitHub, create a pull request, and merge the code into an integration branch, the build and deployment process will automatically begin. Here we can see the build process via Jenkins. In this step, we run some unit tests, build Acme's artifacts, version them, and store them externally for deployment. This includes bundling the ADF. Once the build process completes, Jenkins will automatically trigger Spinnaker for the deployment. Before rendering the deployment pipeline for Acme, it must pass through a preliminary pipeline. This preliminary pipeline consumes the ADF and passes it to two stages. Firstly, in the account generator stage, Spinnaker calls out to our service registry and requests the account coordinates for this service, given the environments and regions specified in the ADF. Here we call them deployment coordinates. Secondly, in the skipper stage, Spinnaker runs a CLI tool to render the deployment pipeline on behalf of the service, hydrating that pipeline with the recently found deployment coordinates. In this case, because we added a new region, the environment region mapping does not exist in our service registry. As a result, our automated AWS account provisioning tool is triggered to create the account and networking needed to deploy the service into this new region, EU West 1. If we decode the deployment coordinates, we can see the account information for all the previously deployed environments and regions, as well as the newly created account information for the EU West 1 production expansion. With the skipper stage complete, the deployment pipeline should be rendered for Acme, and we can explore what's happening there. We can now see a newly added AWS account for our production environment in EU West 1, Acme P EW1. Additionally, there are more stages in the pipeline for this EU West 1 deployment. We can see the original deployment stages for development in US West 2 and staging US East 1. Now that we are deploying to multiple regions in production, there is a parallel branch rendered for both US East 1 and EU West 1. This process can take some time, so we sped up the video quite a bit. Now we can see the full deployment completed. Once again, to verify the application is deployed into EU West 1, we can find the load balancer under the Infrastructure tab. Scroll down a bit to find Acme P EW1. Here we can see the domain name includes EU West 1. If we click on it, we can see our Fox, happy to be in Europe. You may have noticed that we never had to manually configure or redeploy Spinnaker when the new AWS account was created. This is because of a new plugin that we built in collaboration with AWS. I'm now going to hand it off to Gaurav to talk through this plugin in more detail. Thank you.
Thank you, Cole. Good morning, good afternoon, and good evening. My name is Gaurav Dhamija, and I'm a Senior Customer Delivery Architect with AWS Professional Services. As Cole demonstrated earlier, Autodesk was able to completely automate process of rolling out services in new AWS accounts using Spinnaker. Now, one of the challenges that they had was to enable Spinnaker to dynamically fetch AWS account details from their service registry. Traditionally, this would have involved a manual step to update Spinnaker configuration and restart CloudDriver microservice. Considering the scale of Autodesk, this would have limited their ability to roll out new services and also potentially disrupt existing deployments. To address this challenge, Autodesk, Armory, and AWS Professional Services collaborated to develop an open source solution in the form of a Spinnaker plugin. This solution, as you can see on my screen, is hosted on GitHub and has been donated to Spinnaker plugin organization. If I scroll down a bit, what you see is the details related to registration and configuration of this plugin. Overall, this solution extends Spinnaker CloudDriver microservice to fetch AWS accounts information from an external configuration store. It periodically polls external store and maintains a timestamp-based bookmark to fetch any incremental modifications. The key configuration parameters for this solution includes the endpoint URL of external configuration store and the polling interval. From authentication perspective, as of today, this solution supports IAM-based authentication. If we scroll down further, we can also find an example payload supported by this plugin. I will discuss in more detail about the various fields of this payload as I give a demo of this plugin. For the purpose of this demo, I have set up a Spinnaker environment hosted on Kubernetes and provisioned using Spinnaker operator. What you see on my screen is various Spinnaker microservices hosted in Kubernetes pods, and two of them, which is Deck and Gate, have been exposed externally to be accessible via browser. Let us now look at various Spinnaker accounts currently available in this instance. For this, I'll have to navigate to Credentials endpoint of Gate microservice. In the response, as you can see on my screen, we have two Spinnaker accounts, one each for AWS and ECS providers. Both of these accounts were configured as part of Cloud Driver microservice configuration. I have also set up a sample service registry which has an endpoint to provide a list of AWS accounts. Let us invoke this endpoint and have a look at the list of AWS accounts available. These accounts that you see on my screen have not yet been registered with Cloud Driver microservice of our Spinnaker instance. The key fields in this response includes AWS account number, list of providers applicable for respective AWS accounts, and the timestamp for when this information was last updated. The timestamp field is useful to ensure that plugin is fetching only incremental modifications and not reprocessing the entire list of AWS accounts during each sync cycle. As the next step in this demo, I will register and enable the account registration plugin. For this, I will update the custom resource definition for my Spinnaker instance with plugin configuration and then trigger an update on my Spinnaker instance. Let me show you the plugin configuration as part of the CRD before triggering this update. As you can see here, we have plugin configuration in Profiles section of Cloud Driver microservice. It includes key parameters including service registry URL as previously mentioned in our conversation. We will now activate this plugin. As our plugin is getting activated, we can switch over to the logs for Cloud Driver microservice. Here we can see in the logs that plugin was successfully downloaded and registered as part of Cloud Driver initialization. If we scroll down, we can also see the logs indicating that plugin invoked endpoint of service registry. It was also able to successfully register new Spinnaker accounts based on the response received. If we navigate back to the credentials endpoint of Gate microservice, we can see 3 additional Spinnaker accounts added to Cloud Driver microservice. Account registration plugin will continue to pull incremental changes from service registry and continue to update configuration of Cloud Driver microservice. This does not require any redeployment of Spinnaker instance or restarting of Cloud Driver microservice. Overall, this solution has enabled Autodesk to completely automate end-to-end process of rolling out services in new AWS regions and achieve desirable level of enterprise agility. Thank you everyone, and I'm going to hand over back to Brandon now to continue with the rest of the session.
Thanks, Gaurav, and thanks for everyone who came together to make this presentation possible. There are amazing teams of engineers, product managers, product owners, program managers, and designers from Autodesk, AWS, and Armory that all came together to work as one team to drive this project. Now we'll leave you with some resources from AWS to follow up on. Hope you enjoy the rest of reInvent, and thanks for watching.